So this is a hard triple Venn diagram problem, and I will set it up algebraically. So the first condition we're told is that all students choose at least one of the three subjects. So that means that if we consider the entire box here, there's no one here, meaning there's no student here that hasn't chosen a single subject. So this entire box totals 150. Now what I'll do is I'll define these variables here, A, C, B, D, and these represent that region itself. So when I look at B here, that would be the number of students who are taking physics and math, but not chemistry. So each of these letters represent that region. So I'll first algebraically translate that relationship. The number of students who choose both physics and chemistry, that would be A plus D, is equal to the number of students who chose both chemistry and mathematics. So that would be A plus C. So from just that equation, we know D is C, and we can actually just eliminate that variable, meaning that equation is equivalent to me replacing that with C. Now this is also equal to half the number of students who chose both physics and mathematics. So that would be B plus A. Now I can clean up this equation algebraically. 2A plus 2C, I'm moving that 2 here, is equal to B plus A. So that means B is A plus 2C. In fact, I can kind of eliminate that and replace it with A plus 2C. So essentially, I've kind of taken all that, and now I've incorporated in this figure. I just have these two variables. And of course, I have all these numbers, the total number of people in these circles individually. So next, I will phrase what we're looking for is the maximum possible number of students who chose physics but not mathematics. So I have to exclude this region from the physics. So if I call this X here, meaning students who chose physics alone, we're trying to maximize X plus C. So this is what we're trying to maximize. And I also know that 75 has to equal sum of all these three regions. So that's my other relationship. 75 is equal to X plus C plus A plus 2C. And that becomes 3C plus 2A, which means X is 75 minus 3C minus 2A. I can plug that back in, and that way I have an expression explicitly in terms of A and C that I need to maximize. So this becomes 75 minus 2C minus 2A. This is what I need to maximize. Now, is there a relationship between A and C? Yes, there is, because we know that the total number of students is 150. So if I add all of them, that must equal 150. And the way I do this is, and there are different ways to do this. You could say this whole circle is 75. So 150 must equal 75 plus, actually, it's easier because I already have X. I want to use that one. So what I'll do is instead use that entire circle. I think it's kind of getting messy. Let me change the color here. So I'm going to call that entire circle as 111. And then it would be 111 plus that region, which is X, because I already have X explicitly, plus C, and then plus what's remaining here, which to get to that, I have to subtract C, and A. So 40 minus A minus 2C, which is this region here. So then I plug in. Yeah, this part can be confusing for some students, but I mean, you could add individual regions, but then to find this region here, you have to subtract, so it's more algebra. But if you instead call this entire region 111, then all you have to do is to figure out these remaining three regions. So that's the step, but eventually you'll get the same answer. So 150, these two become 151 plus X minus A minus C. And then I will plug in what X is and then subtract that. 1 and X is this piece here. Minus 2A minus A minus C. So I get, I'll move these other terms to the other side. I get 76 is equal to 4C plus 3A. Now, eventually my goal is to maximize that, so I will isolate 2c because I have a 2c here. So 4c is 76 minus 3a. 2c would be half of that. And that I can plug in back in here. 75 minus 76 minus 3a over 2 minus 2a. So that becomes 75 minus 38 plus 3a over 2 minus 2a. And that's going to become 37 minus a over 2. So that's the expression I need to maximize. Now, a node has to be greater than or equal to 1. So the first temptation might be that a is 2. But that's not the case because c also has to be an integer. So c is 76. So that's the tricky part in this question. If you chose a equal to 2, you'll see c is not an integer because this would be 70 over 4. So you have to get to the next even number that's greater than 2. That would be 4. Because remember, we're trying to maximize this. So the lower we can keep a, the higher our maximum possible value would be. So if a is 4, we can plug that back in here. 76 minus 12 over 4. Is that an integer? Yes, it is. And in that case, if you plug in a equal to 4, I get 37 minus 2, which is 35, and I get my answer. So it's a hard question. I mean, this is how I approached it. The reason I take the algebraic approach is that there's less in terms of logically arguing. I mean, all you have to do is to write the equations, and you simplify, and finally you get to that equation, and then you see what's the least value you can pick. So it's just easier, in my opinion, from a, I guess, stress on your brain point of view. But there may be other ways to do this logically, or but I think what makes it hard is that with these types of relationships, it's difficult to kind of argue logically, at least for me. So see if there are other ways to do this that are easier for you. But this is kind of how I generally approach these types of triple Venn diagram questions, where these relationships, are fairly convoluted, and it's very difficult to see through what they conceptually mean. So to summarize, the answer is B.